Okay, good afternoon, everyone. So I'll be the teaching assistant for this particular, for the course Laplace transforms. So the work that I am expected to do is basically solve the assignment questions uh, for you all. So I hope all of you are following the lectures and stuff. Uh, is my voice audible? Can anyone say yes?
Yes,
Yes,
you're
yes.
audible.
Yeah, yeah. So because I mean it is not advisable that everyone of us speak. So can I ask Sarfaraj Muhammad? Will you be able to reply to me so that I not
Yes,
able,
sure, sure.
okay, so that all of you might shouldn't unmute. Okay. Yes, people are still joining. Let's wait for some more time. Let's for it for five more minutes. I guess people are still joining. After that, we'll start. Okay, I'll just paste the link of the set of questions that we are going to solve today in our chat box so everyone can access it. Okay, so I just suggest uh, don't turn on your video streaming thing. I think that will consume more of net or something like that and might cause break. So don't turn on your video. Uh, Okay, so I have pasted the link of questions that we are going to solve today in the chat box. So can I'll just start sharing my screen. So Sarfaraj, is my screen visible?
Yes, yes, it is visible.
Okay, you're not audible, but
Hello, I'm not audible.
okay, I'm audible, right, Sarfaraj? Okay, fine. I'll start then. So we have this assignment for Laplace transforms. So this is assignment 0. Yes, we'll solve these questions one by one. It will be better if you try to solve along with me so that if I make any errors or you can suggest some simpler steps or something. Okay. So this is our assignment 0. And uh, Sarah Silpa, can you mute yourself? Because, uh, okay, fine. Okay, I'll stop taking requests from now on. I guess it's 5, 6. So it will be an interruption if I continue taking requests after 3, 5. Okay. So our assignment 0 is basically some revision of basic calculus. I think this is our +1, +2 stuff. So let's do with that. So the first question is limit x tends to 0, √3 plus x minus √3 by x, right? limit x tends to 0. Root x by x. Right. Okay. So I'll just differentiate this. I mean, it's better to use L'Hopital rule, 0 by 0 form. So 1 by 2 times 3 plus x. I'm just differentiating this. Minus half minus 1 by 2 x power minus x and 0. So the L'Hopital doesn't work. Have to try with some other method. 2 3 times 1 plus x by 3 power half x power. No, it's not.
Excuse
It's
me.
3. It's
Yeah,
3, right? Yeah.
yeah.
Sorry. Then it will work. Yeah. So it's basically 1 by 2 times root 3 minus the 1 by 2 times. No, this will be 0 actually, right? So 1 will 0 and just differentiate it. So it will be 1 by 2 times 3 plus x whole power minus half. And x tends to 0, so it's basically root 3 by 2.
It will be 1 by 2 root 3.
Yeah. 1 by 2 root 3. Yeah.
Hello, sir.
Yes.
Sir, I asking on question.
Yeah.
Assignment question root 3 sir next step. Anna, but you in root x.
Yeah, you're right.
Question is
Yeah, you're right. So it's like, sorry. It's basically 1 by 2 times uh, 3 whole power minus half. So, sorry. Yeah. Okay. It's better if I just. And I think I can understand a little bit of Tamil, but I don't know if everyone can. So it's preferable to speak in English or Hindi. Uh, okay. Let's go to the next question. I guess sine 3x by 6x, it's pretty straightforward, right? It's half. I hope nobody has a doubt on this. You can use L'Hopital rule again. Just differentiate it. So you'll be getting 3 cos 3x by 6. You could substitute 0, so 3 by 6 and half. Okay. Now this is interesting. Okay. Limit h tends to 0 minus 4h by. Okay. We'll try this question. Limit h tends to 0 minus small of 4h by h. Just look at the graph. If h is greater than 0, place the function becomes minus 4h by h. If h is less than 0, place it is minus 4h by h, right? So it's basically 4 and minus 4. If h is greater than 0, then it is minus 4. If h is less than 0, then it is plus 4. So basically limit h 0 plus minus mod 4h by h is not equals to limit h tends to 0 minus mod of 4h by h. Logically the limit shouldn't exist. Let's see what it says there. Minus 4 is the answer. Interesting.
Can I say something?
Yeah, please.
Yeah, when you consider the case when limit h tends to 0 minus, so
Yeah.
the h which is in denominator will become negative. So overall it will become negative. So both limit will be same, I guess.
Uh, just a second. Okay, when we consider if h is greater less than 0, if h is less than 0 implies what? Minus mod
It
4h
means
by
that
h.
it means that
Implies,
h is negative. So the h which is in denominator will be negative, right?
yeah, but whatever it is, so this is negative. You just have to change this. So this will be 4h by h. It won't, I mean, the sign of this
That
doesn't
is
change.
correct, brother.
Like, for example, minus 4 of minus 2 by minus 2, right, is equals to what? Minus of 4 into minus 8 by minus 2. So, which is basically minus 8 by minus 2. So, it's 4, right? So, logically, the limit shouldn't exist. But let,
Okay, okay, yeah,
yeah,
yeah.
yeah. Let's get back to that after a while. These things do happen, and that's is not that, not like, hmm, okay, we hit the ball and things go to the goal. Okay, let's try the next question. 3 by 1 plus t square as t tends to infinity. Yeah, something obvious, right? So 3 by infinite, so it's 0. Actually, I mean, I'm doing things in a very hand waving way. I mean, these require far more robust proofs, but I think they are out of the scope of this particular NPTEL course. So, okay, fifth. There exists a function that is discontinuous at every real number. Okay, so uh, please Google something called Weierstrass function. Oh, okay. Sorry. They cannot be. Okay, yeah. Google this anyway. Weierstrass uh, functions. I mean, functions which are continuous everywhere. Functions which are continuous everywhere, but differentiable nowhere. So this is an interesting theoretical concept where basically, so say if a function is continuous, does that mean we can differentiate it every point? For example, we have function like this. Say a function like this. This is a continuous function, but you can't differentiate the function at this particular point. So is there? So this is one point at which we can't differentiate, right? So are there any set of continuous functions which are not differentiable everywhere, at anywhere? So it turns out that there is a mathematician called Carl Weierstrass. He basically constructed a function which basically looks something very, very sharp at every point that you can't differentiate it at any point. So this is something that you can look at if you're interested about theoretical aspects of things. But then the question is, I guess, uh, are there functions which are discontinuous at every real number? So that is not possible. But then again, I'll just try to find out a theoretical justification and I'll explain it in the next tutorial for this. These kind of questions are not that easy. You have to Google and things. Okay. Which of the following is true for the function mod x minus r? So basically, it is from the graph that I have drawn before. It's basically differentiable at 1 and not differentiable at 2, right? So yeah, it's differentiable at 1 but not at 2. Okay, let us try this. Sorry, I mean it's some basic calculus thing. We'll get to Laplace transform, I guess, in next week. Limit x goes to pi by 2 cos x by x minus pi by 2. This 0 by 0 form, we can use L'Hopital rule, minus sin x by 1 plus minus 1 is the answer. But let us try with some other way. Can we try it with x minus pi by 2 plus pi by 2 by 3? I mean, we have used uh, L'Hopital rule. I'm just trying if we can use even Taylor series. So f of x plus h equals f of x plus h times of f dash of x plus h square by 2 factorial times f double dash of x. So we have, this will be cos of pi by 2, I'm taking it to be x, and h will be x minus pi by 2. So cos x into f of x is what? F of cos pi by 2 plus h is x minus pi by 2 into f dash, which is minus sine of x. X is pi by 2, right? Again, these terms anyway, they'll get cancelled. I mean, you have an x minus pi by 2 term here plus x minus pi by 2 whole square by 2 factorial. So yeah, the higher order terms will get cancelled anyway. So the term, so this is 0. The term that is remaining is minus sine pi by 2, just minus 1. Yeah. So even by Taylor series expansion, we'll get the same.
We can do it in one other way also. Like
Yeah.
we can write cos x as sine pi by 2 minus x.
Yeah.
So it will be sine x by x form.
Right. Yeah, yeah. That's one more way. Yeah. Thank you. Yeah, yeah. There are these many ways. Okay. These questions are not, I mean, discussing in much depth or detail because once we get into Laplace transform thing, we'll get into deeper stuff and we'll try each question by 3-4 methods and so on. Okay. This is just some basic muscle building exercise on calculus and stuff. Okay. So what for what values of x does the graph f of x equals this particular polynomial have horizontal tangent? So what he's saying is that slope has to be 0 at those points of x. So we can just differentiate. What is the polynomial again? F of x is 1 by 3 times of x cube minus x squared plus 3 squared plus 3, right? So f dash of x equals x square minus 2x. So I mean, I'll just draw a rough sketch of this polynomial. X is 0, this is 3, right? And if x is 1, it's roughly 3 by 3 is 2. Okay. Again, this is not to be scaled. I am just drawing it roughly. He's just asking the points at which the tangent will be parallel to x-axis. So slope has to be 0. X into should be 0 implies x is 0 and x is 2. So at 2 and 0 it will be parallel to x-axis. Okay. Okay. The equation has a solution in the open interval n into n plus 1, where n is a positive integer. Okay. X power 4 minus 6x square minus 53 should 22x minus 2x cube. Okay. Minus 2x cube. We should have a solution in an open interval n comma n plus 1, and we have to determine what is n. Can we use any theorem? Yeah, one easy method is okay, we can find f dash of x. From that, we'll be getting some horizontal tangents. It can be like this. Okay, if we find any 2 points, okay, so my approach is this way. You can tell if there is another optimal way. I differentiate this function f dash of x and then try to find the roots of this. So we'll be getting how many roots? 3 roots, right? Some x1, x2 and x3. I just compute the value of f of x1 and f of x2 and f of x3. Then say if these both are in different directions. I mean, if these both are in alternative directions, then there must be one root in between the interval x1 and x2. Right. I hope you get, I mean, you're able to understand this method. So what? Okay. So there is a function, right? Say hypothetically it's like this, say, right? So what I'm doing is I'm just trying to calculate the values of points at which the function is parallel to x-axis. I mean the tangent of the function, the tangent of the function at that particular point is parallel to x-axis or not. And I'm just verifying if they are in opposite signs, because it can happen that function can be like this. So in this case, you will get the slopes, but it might not be true that you have any root in between these two intervals, in this interval. Okay, let us try this approach. I think this is a non-optimal way, but I'm not able to think better method to solve this question. Okay, sorry, done. Okay. X power 4, x power 4 minus 6x minus 53 equals 22x minus 2x cube. X minus 2x cube. Differentiating this, we get 4x cube minus 12x equals 22 minus 8x square plus 4x cube plus 8x square minus 12x minus 22 is 0, right? Okay, plus 2x cube plus 4x square minus 6x minus 11. Okay, you can solve it in any ways. I just prefer to use. Just trying to solve the roots of this. Anyway, we have to solve, I guess. I mean, if we are going to solve the roots for this, what's the problem in solving the roots for this?
I think there is a mistake.
Yeah.
Like in the second line, the derivative of minus 2x cube should be minus 6x square. You have written minus 8.
Sorry. You're right. You're right. Thank you. Minus 6x square. Okay, so we'll be landing up with 3, right? 3x square. Is minus 1 a root 2 minus 1 plus 6 minus 11 minus 2 plus 3 minus 5. Okay. Sorry, I'll just write a simple MATLAB code for finding the polynomial. X cube x cube square 3 x cube plus 3x square minus 6x. This is the okay. So these are the roots of this. It doesn't have an alternating. I mean, it doesn't have real roots. So I think my method is flawed here. To think of some other way. Okay, I'll get back to this question in next tutorial. Question 9 and another question wasn't solved. Question 5, theoretical aspects of question 5 are not solved. And I'll just check on question 3 too. Minus out of 4h by h. Yeah. These 3 questions I'll get back in next class. We'll discuss in detail. Okay. Which of the following statements are true? Okay. If a limit x tends to a, f of x minus f of a by x and say, then f is differentiable at a. Yeah, I think this is basically the definition of the differential operator. So this is true. If f is, so you define differentiation this way, right? So f dash of a is defined as limit extends to a f of x minus f of a by x minus a. So this is by definition true. Okay. F is continuous A, then F is differentiable at A. This is not true because we can produce a counter example. Nothing but mod x function. So it's something like this, right? It's continuous at 0, but it is not differentiable. So B is false. If limit extends to f of x exists, then f is differentiable at A. So even this is false because the same example is valid for the third option. So you have this function mod x, limit mod x extends to 0, it exists, it is 0, but you don't have any value of the differentiation. I mean, the derivative is not unique at this particular point. F is differentiable at A, then limit extends to A, f of x equals f of A. See, this has to be true because if f is differentiable at some point, if f is differentiable at A, implies if f should be continuous at A, implies f of x as x tends to a should be equals to f of a. So these are some basic real analysis stuff. Okay. So y is 5 power 3x plus sin x. So just they're asking that for the derivative of this. So it's basically 50. You can do it in mind 15 e power 3x plus cos x. Yeah. Okay. So now we have a question on what intervals the function x cube e power x is increasing. Okay. F of x equals x cube e power x. So he is basically asking f dash of x has to be greater than 0. Implies 3x square e power x plus x cube e power x has to be greater than 0. Implies e power x into 3x square plus x cube. Let us just try to draw this graph. So 3x, so because this doesn't change its sign anyway, we're not that much worried about e power x. But then 3 e power x square plus x cube, just try to draw this function. X is equals to 0 is one of the root and x is equals to minus 3 is one root. As x tends to, so I guess most likely the graph will be something like this. No. Sorry. X square into x plus 3. Right. At minus 3 it is 0. At 0 it is 0. Okay. Say I take minus 2, what is going to happen? Minus 2 whole square into minus 2 plus 3, right? So it's 4 times 1. It will be positive here. Okay. Okay, okay. So as x goes to, if x is less than minus 3, so minus 4 whole square into minus 4 plus 3, right? Minus 1 into 16. So this is negative. Okay. And what about this? This one has to be positive. Maybe it's something like this, I guess. Concave curve and it goes on this way. So I guess this particular function is increasing from the interval minus 3 to infinity, or else it's a decreasing function. Yeah, minus 3 to infinity, it has to increase. Q. Q. Okay. Oh no, no. Okay. This string appears to be hmm, something strange is happening. This graph is appearing to be highest. This okay for analysis part. We shouldn't use these kind of Google searches and MATLAB simulations and stuff. But once we have performed our analysis to verify, we can try.
I think you should write
Yeah,
plot F2.
yeah, yeah. Beta must remember. Okay, F plot. Okay. Somebody. Yeah. So I guess what we are doing here, yeah, F plot F2, right? Functions are too high. Okay. So I'll stop admitting students after 3 5 from next time because constant this thing is actually the graphs are varying too high that not able to decide whether it's decreasing or increasing. I'll take the questions at the end and also give you my contact number so that if you have any doubts, you can. Okay. Okay. From 1 it is increasing. There's no doubt in that. So just let us keep our interval analysis from -5 to this. Okay. So from -3, yeah, it is increasing. Then it should also be so. Okay, it's decreasing. Yeah, if you see from -5 to -3, the function is decreasing. So let us see. Yeah, so the function is. Yeah, so our answer is right. From -3 to infinity, the function will go on increase, and from obviously at -infinity, the function will be 0. Uh, so it will be slightly decreasing, and so on. At -3, it will reach its minimum, and then it will increase. Yeah. Okay, let us try question 30. F of x is f of g of x, and f of 2 is -8, f of -2 is 4, f of 5 is 3, g of 5 is -2, g dash of 5 is 6. Okay. Okay, so they have defined a function f of x is some f of g of x. Okay. F of -2 is 8, f of 2, f of 5, dash of 5. F of -2 is 8. Okay, I'll just write the data. F of -2 is 8. F dash of -2 is 4. It's 4. F dash of 5 is 3. Okay, I'll just close this MATLAB. F dash of 5 is 3. And then g of 5 is -2. Is g dash of 5 is 6. Hope I wrote the data well. So they're asking for f dash of 5, I guess. So f dash of g of 5 into g dash of 5, right? So which is nothing but f dash
F
of.
dash of 5 is 6.
Yeah. So g dash of f dash of 5 is 6, right?
6. It's
Oh,
not -6. Sorry, G dash of 5 is 6. You have written it's -6.
okay. Just a second. Okay, so f dash of phi is what? Uh,
It's 3.
f dash of phi is 3 and this is 6, right?
Yeah, this is
Okay,
6.
okay, thank you. G of phi is minus 2 and g dash of phi is 6. F dash of minus 2 is 4 given. So 4 into 6 is 24. Simple question. Kind of terrified me at the beginning. Okay, so let n be a positive integer and let f of x be x power n plus 2 sine 1 by x. Let f of 0 is 0. For what value of n will f be twice differentiable but its second derivative discontinuous at x equals 0? Hmm. Yeah. Okay, so we just have to differentiate it twice and see. So f of x equals x power n plus 2 into f of 1 by x. Sorry, sine of 1 by x. Sorry. Into sine of 1 by x. So let's differentiate this. N plus 2 x power n plus 1 sine of 1 by x plus x power n plus 2 into cos of 1 by x, sorry, cos of 1 by x into minus 1 by x square. So you have to differentiate this again. See, if first, okay, let us assume, okay, let us just simplify our question, and if first derivative has to exist, then n plus 2 has to be, uh, yeah, so basically x power n plus 2 by x square has to make sense at x equals 0. That will make sense if n is equals to 1. From this, we can guess that for n is equals to 2, the second derivative will make sense. But then again, let us differentiate. N plus 2, 2 plus 1, x power n, sine of 1 by x, uh, plus n plus 2 into x power n plus 1, cos of 1 by x into minus 1 by x square. So n should be 1, at least 1 for this to make sense, plus n plus 2 x power n plus 1 cos of 1 by x into minus 1 by x square plus n plus 2 into x power n plus 1. I'm making a mistake here. I could have just plugged these things. Sorry. Okay. I should have plugged them. N plus 2 x power n plus 1 sine of 1 by x plus, sorry, minus 1 into x power n cos 1 by x. So this term looks fine. I mean, if for certain value of n this derivative, if it makes sense, it will also make sense for this one because it has an extra x term outside. So we'll just differentiate this x power n minus 1 n cos 1 by x plus minus 1 into x power n into minus 1 by x square. Yeah, so for this, so if n is 3, we can say that second derivative will exist. But for n is equal to 2, what will happen is these terms will get cancelled and we'll have sine of 1 by x thing. So this kind of satisfies our question and the requirements in our question. So n has to be 2. Okay. Yes, we have 5 more minutes. I'll just choose some questions right now. Okay, we'll just try this one. Some ODs, and we are going in a monotonous fashion. So let us go for, yeah, we'll solve 19, 18, and then 20. Let us try for that. Okay. So we have to solve. Okay, this basically connects our Laplace transform things. Okay, we'll solve this 19th question. Solution of the differential equation which passes to the point this thing. So we have this OD 3x square d square y by dx square plus 3x dy by dx plus minus y equals 0 and y of 1 equals 1. So we have to solve for this particular OD. So any idea, can anyone just give an idea on how to solve this OD quickly? Any attempt? Does this OD look in a format that you know or something like that? So this I'm solving on intuitional basis right now. Intuitional basis. But if we proceed on in our course, once we get our hands on the Laplace transform, we'll solve this more robustly and more methodologically. For now, I'm just guessing my y should be in the form of some x power m. Okay, so 3x square into m minus 1 into x power m minus 2 plus 3 times x into m times x power m minus 1 minus x power m equals 0. So we just cancel out the x power m term both sides. So we'll be having 3 times m into m minus 1 plus 3 times m minus 1 equals 0, implies this is 3m square minus 3m plus 3m minus 1 implies 3m square minus 1 equals 0, implies m should be what? Plus or minus 1 by root 3. So your solution for this OD will be of the form c1 x power 1 by root 3 plus c2 x power minus 1 by root 3. Are there any more conditions? Okay. Oh, this is 2x square. Okay, sorry, I wrote this as.
So y is equal to 1 by x is the solution, right?
Yeah, sorry. See, what I've done is, yeah, I, I wrote this to be 3. This is 2 actually. Just a second. So we'll be having 2 times m into m minus 1 plus 3m minus 1 equals 0 implies 2m square uh, plus m minus 1. So let's try to m equals minus 1 is satisfying. Okay, 2m square plus 2m minus m minus 1. So 2m times m. So m is equals to half and m is equals to minus 1 are the solutions. So the solution of the ODE is c1 some c1 by x plus c2 times x power minus half. But I don't see any extra conditions. Oh, for x greater than 0. Okay. I don't see what are the extra conditions for which we can actually remove x power minus half. Say if they say it's a bounded solution at x equals 0, we can, I think we may remove this. But okay, yeah, but still not getting the rationale behind why should we remove this. Okay, let us, okay, we'll remove that and we see c1 by x. Okay, at 1 equals 1, so c1 should be 1. We can understand that. And from the options also, we can check. I mean, it's not that big of a problem, but the rationale behind removing. Okay, I think 1 by root x won't satisfy this. Okay, so right now the candidates are y equals 1 by x and y is equals to 1 by root x. So just plug this in the differential equation and check if we get the same answer or not. I don't. Yeah. Okay. Let us try another question and we'll end this. So every continuous function is Riemann integrable. Again, this goes into more theoretical stuff of mathematics where I have to bring some real analysis and so on. Just avoid that. Okay, we'll try this simple question and then end things for today. So, yeah, this is kind of direct. Just substitute, just differentiation under integral side, the Leibniz rule. So this will be e power x square whole square. So e power x power 4 into differential of this. So 2x. So 2x e power x power 4 minus e power x square into x dash. Option A is right. Okay. With that, I'll end today's lecture, I guess. I'll just share my number. So today, things went in a somewhat hand-weaving way because we are just revising some basic stuff on calculus and so on. From next class onwards, we'll get into Laplace transforms and some real stuff. Okay. Okay. Yeah. Okay. I'll just take this feedback. Video professor, please explain clearly. Yeah. Sorry. Even fundamentals, I'll explain. Okay. I thought these were like El L'Hopital rule and so on, and kind of fundamental. So But from next class, I'll just keep this in mind, and I'll try to do less questions, but I'll do the questions very thoroughly such that I uh, cover every aspect of thing. In each question, I'll do it in 2 3 ways so that we can understand the concepts better. Sorry if I was somewhat fast today. Okay, I'll just type in my number. Please feel free to message me in WhatsApp, or this is my WhatsApp number. You can message me in WhatsApp if you have any doubts. I'll clarify them. Yeah. I guess with that, I'll end today's class. You are free to leave. Yes, Sivahakti? Yeah. So we are done with the class. You can leave if you want. Yeah, you're free to leave. Yeah, we'll meet for the next class on Sunday 3 p.m. again. So we have 3 more classes. Thank you for joining. And I have typed in my WhatsApp number in chat. Uh, Whenever you have doubts, in general, I work on partial differential equations, real analysis, functional analysis, and so on. If you have any doubts in those stuff, even you're free to message in to my number. Yeah. Welcome everyone. Sorry, I went fast a little bit. Yeah, I'll try to reduce the speed next class. Okay, I'll end the meeting for everyone, and yeah, please note down. I mean, if you're interested, if you want to ask doubts, note down my number. You can WhatsApp me anytime. Okay, I'll end the meeting for everyone. Thank you for coming. We'll meet on next Sunday. I didn't, I didn't end the meeting for everyone. So what's the option? I guess you have to leave. That's it. Okay, okay. Fine. I'm leaving then. Meet you on next Sunday.